Good morning, everyone. We're excited to have a visitor here with us this morning. This is part of the worldwide climate teach-in here at MassArt. For those of you joining us online, we have a room full of people here in the Collins building at MassArt. We also probably have some other rooms of people who are logging in. And this is a great opportunity for us to share a lot of information. This little talk that Nancy's doing, we've agreed is being recorded. So if you do want to see it again, and also Nancy's graciously offered to share all of the PowerPoint slides that are here that you can also continue to look at the information. There's a lot here, and so you will be able to, you don't need to take notes, but you may want to highlight some things yourself. So because our time is short, I just want to say, Nancy and I have known one another for many years because she was a longtime director over at Harvard Ceramics before Kathy King actually assumed that position. But Nancy also was very involved with a lot of bringing programming in from around the world, looking at different practices from around the world. And then once she stepped away, she had more time for her own work and research. And this became sort of, should I call it an obsession, Nancy, to be aware, because for us each to contribute to how we can do things better. So Nancy's own work, she works in public art with multiple types of materials. And she's here to share all this information with you. So Nancy, let me turn it over to you, and you go ahead and tell anybody anything else you want to add to your own bio here.
Oh, I won't add to the bio, but I will say that the presentation is somewhat focused on ceramics because that's the area that I was an educator in for many years, and also because this is offered by the ceramics department. But there will be information about other materials and strategies for dealing with offsetting any carbon emissions you might have generated from using other materials. You're welcome to interrupt me at any point with questions that relate to a specific slide, and but otherwise I will forge ahead. So the focus is how can we protect the environment and help mitigate climate change? And we'll be considering resource conservation, carbon dioxide emissions, how to offset those carbon emissions with carbon offsets or renewable energy credits, and other sustainable options. Oops, what happened? Oh yes, I have to click the screen to advance it, not my keyboard. Oops, gotta put you guys down there. The intersection of culture and nature is a critical focus for contemporary artists and designers. I don't know where I got it. There it is. But creating work to address this relationship becomes very problematic when the art making practice itself contributes to an unsustainable balance between the cultural expression and the natural resources. Efforts to establish a sustainable balance are generating new technologies, production methods, expressive strategies, and aesthetic values. Knowing how to evaluate and improve the environmental impact of one's art practice is a critical survival skill. We need to comply with state and federal environmental regulations and contribute to institutional energy goals. We need to address sustainability questions and concerns that might be posed by potential clients. This is some fair a few years ago in Ireland. Sustainability, the key trend. Lots of greenwashing, probably. We might need to provide detailed energy information about our artwork to juries who are evaluating proposals for LEED certified projects. Those are projects that get various points for being leadership in environmental and energy design. And we need to determine the most effective approach to reducing our unique environmental impact. So what is a sustainable practice? Fundamentally, one that contributes to reducing the carbon dioxide levels, conserves natural resources, and does not pollute the environment. Since the global infrastructure and political will for replacing fossil fuels with renewable energy is lagging far behind what is necessary, an aggressive mix of conservation, carbon offsets, and renewable energy development is critical immediately. There was a big report that came out from the UN just in the past few weeks. It said we were very far behind to keep climate change not within tolerable levels, and that we had to act within the next 10 years or things were really going to be bad. If our studio practices are not on track to be powered by 100% renewable energy within 10 years, we cannot claim to be sustainable. Oops. So as you all know, and have the carbon dioxide levels are rising from 275 parts per million 200 years ago, almost doubled to 431 and rising each year. Experts consider the highest level to avoid catastrophe is 350. So we have to get back to 350 as soon as possible. Embodied, the energy that's used to create different materials is, some materials is on this chart, with the materials at the lower end embodying less energy, and the materials at the very top, aluminum, embodying the most energy needed to produce it. Now, embodied carbon, well, let's see, embodied energy is not necessarily bad if the energy is renewable and sustainable and doesn't, create carbon emissions. But this chart assumes that there's embodied carbon in the production of these materials. We're going to talk a lot about ceramics, and you can see porcelain is up here. Can you see my little cursor on your screen?
Yes.
Yes.
Okay. Yeah, I didn't know if that came through. So yeah, porcelain is pretty high here, and low fire ceramics like brick is further down. Wood is somewhere in the middle. And aluminum is way at the top. So I'm going to, since I use a bunch of aluminum in my work, I'm going to show you, I'm going to focus on that for a minute. So if I say, oh, yeah, I know how many sheets of aluminum I buy for my projects. I know how much it weighs. I can calculate, how much I'm using. But if I go to a chart, I'm sorry, this is a little blurry, to see how much embodied carbon might be in that material, if it's virgin material, on the average, it's 224 megajoules per kilogram, anyway, a lot. But it could be a minimum of 40, or it could be a maximum of almost 400. And how am I going to find out from my supplier what I'm getting, and whether I'm getting 50% recycled or, whatever. So I have to make some sort of guesstimate and calculate how much embodied energy there is. Aluminum comes from very benign natural resources, bauxite, which is a non-toxic aluminum ore, which comes from a variety of places. Most of it comes from Australia at the moment. But it takes a lot of energy to pull that aluminum out of the bauxite. So much energy that it makes sense for the bauxite to be shipped from Australia to Iceland, where they have renewable energy, hydro power and thermal energy in the earth from volcanic activity, so that they can use that renewable energy to extract the aluminum from bauxite. So that's probably the virgin stuff that is only using the minimum amount is probably coming from that source. Anyway, so it's a bit complicated. But if we go back, I'm going to go back to this slide. The one thing, even though aluminum takes a huge amount of energy to extract from an ore, it is endlessly recyclable. Once you extract it, you can keep reusing it. And I collect all my little shards from cutting things up and sawing things and put them in metal recycling. But ceramics cannot be recycled once it's fired. Steel can be. So there are a whole variety of factors one has to consider. For clay, this is some chart. This is for industry. If industry uses energy to dry materials, that's if industry uses machines to fabricate stuff. But generally, about 80% of the energy used for ceramics comes from the firing process. So that's why it's critical to consider the sustainable use of firing options. Natural resources. Since clay is replenished by the geological weathering of feldspar, which comprises 60% of the Earth's crust, we do not have to worry about depleting this renewable resource. However, the mining and processing of all materials used in ceramics can have negative environmental impacts. This is a photograph of an abundant natural deposit on Martha's Vineyard, which is unfortunately getting eaten away by rising sea levels. And this is a native Wampanoag woman, Gladys Wittes, who was the only one allowed to use the clay, go and dig it. And she made vessels and canoes that she did not fire so that the different colors of the clay would be preserved. So extraction of minerals is responsible for about 10% of the total global energy consumption, one of the largest sources of carbon dioxide emissions. Here are a couple of pictures of my clay mines. To reduce the energy impact of securing our materials and shipping them from various places, we can make friends with excavators and learn about the geology of our area. When the big dig happened in Boston, there were truckloads of terracotta going past the ceramic studio where I worked, and several people grabbed it and it went to Cone 6 and they made some lovely things out of it. Ooh. In contrast to the abundance of clay, the supplies are limited for most of the minerals used for color in paints, acrylics, oils, glazes, stains, and underglazes. Copper, chrome, cadmium, lead, and tin are essential for reds, pinks, yellows, oranges, greens, and blues. Oh, and now there's a new material for making blue. There is some people in Oregon think it was Oregon, recently were melting a couple materials together, iridium and indium and manganese. And they got this gorgeous blue, the first blue discovered in 200 years. And it's now available for sale. I looked online, but it costs $130 for a few ounces, a few grams, excuse me. But that probably would be work in ceramics. Anyway, I think it costs a lot to make it, but it's non-toxic. And it is being used in paints now.
Nancy, I was just going to say, because we have people who aren't ceramics here, so this color chart really applies to everybody. It doesn't matter if those years usable reserve are just called, just in a glaze, but it could be in a paint just as easily.
Yeah, absolutely. Yeah, if you're using oil paints or acrylics that you want to last forever, and they're not, dyes that might fade over time, then these are critical materials. Glass, whatever. So, and also you're in competition with all sorts of electronics that also want to use cobalt and various copper. So a sustainable practice, would either eliminate all of these, or if they were used, any colorants with these oxides, you would have 100% recovery and reuse of your glazing and stain materials. I'm just going to go, for people working in ceramics, we're lucky because our underglazes and stains are in a water medium, so it's easier, much easier to separate them out and to save them. If your materials are in an oil medium or acrylic medium, there are different strategies for doing that, and you can't really totally separate things out as easily. So you have to rely more on hazardous waste disposal. And there are many sites that are good, but this Princeton University website deals with practices for recycling and working safely with all sorts of painting, drawing materials, ceramics, lithography, relief printing, photography, sculpture, et cetera, et cetera. So that's, and I know that Golden, different companies themselves, like Golden that makes acrylic paints, has their own set of guidelines for how to use the material safely. For people in ceramics, normally the clays are are safe, and you don't have to worry about them polluting the environment. You might have to worry about them clogging drains and things like that. But occasionally barium carbonate is added to bind sulfur in an earthenware body, and barium carbonate is very toxic. So you have to be aware of that. And then in glazes, and even if it isn't colored, the glaze isn't colored, there may be barium carbonate or lead compounds that are helping to melt the glazes. And you have to be aware of that if you don't see any color and you think you're okay, primarily in low temperature glazes. And then all the metal oxides should not go flowing down the drain unless it's just iron oxide, which is pretty pervasive in our environment. So anything else besides iron oxide, you really should reuse, recycle, dispose of responsibly. Now, when I was I'm gonna go, anyway, I'm gonna go back. When I was in the studio, we had to, we collected all the debris and took them to hazardous wastes in barrels, or hazardous waste came to us. This is from Mass Art. Do you guys still have these sinks here in the painting studio? These look wonderful. So these are sinks that deal with oil paint and collect stuff. And I did a presentation with Ian Gage, who used to be at Mass Art, and he brought me this slide. So it's great that in the school you have these facilities, but when you go off on your own in your own studio, you have to recreate it, your own technique for doing things. The reuse and recycling of waste. In ceramics, it makes the reuse and recycling makes a lot of sense, especially on a big scale. So large factories that have tons of waste can grind these up and reuse them as an ingredient in their next batch of stuff. And for ceramic studio, art studios with all of our debris, it's the fired ceramics that can't be broken down easily. And apparently there are some ceramic departments that have found companies that, grind up stuff and use it for building roads and whatever. So I don't know of anything in this area that takes it, but for that particular use, but there are definitely a lot of recycle area companies in the area where you could take, or you can use them to make other things, all those broken ceramics. This is David Binns was working with a partner in the United Kingdom, and they were making these wonderful architectural bricks and slabs from ground up recycled glass materials and clay materials, and just had this wonderful set of innovative, well, I'm gonna get rid of this thing. Wonderful pieces. And Jana just hosted a woman from China who has been using tons of ceramic industry waste in China to also make tiles and bricks and various architectural things from ground up things. So this silica stone starts with all this broken glass as well as ceramics. And then there are also, you can make functional vessels and sculptural vessels and other sculptural objects with broken ceramics, as you all well know. This is some studio that was supposedly being sustainable by firing all the sludge and leftover glazes and stuff in little bowls, but they did put it in a form where it would not leach into the environment, which was good, but they used a bunch of energy doing it. I think that collecting, I think that it's probably better to collect that sludge and letting it, and ideally at some point when the chemicals get to be in such short supply, all that sludge could be a mine for the future. Sustainable energy options for firing kilns. The only real sustainable ones, are non-fuel burning ones like wind, solar, water, electricity. Last time I did this thing, I also had biofuels and whatever, corn cobs But all of that is burned and creates carbon dioxide, and methane also does. But if you use methane, you are preventing it from just escaping into the air, where it's 4 times worse than natural gas for creating carbon emissions. So you can hook up that cow, or there's methane that's been captured in landfills. I think it's rather a bit expensive to do it, but there was a company about 20 years ago, and I think this is still operating in North Carolina. So all the seeping methane is captured and used to fuel ceramic kilns and glass kilns. Whoops. So it would be great if we could use solar power to directly fire kilns. And some of the early ceramic kilns were fired with solar power. This was Lavoisier, who was working with von Charnes, who was trying to figure out how to make porcelain. For 1,000 years, the West and the Middle East have been trying to imitate Chinese porcelain. And finally, it happened with the concentrated power of this magnifying glass, creating a very hot spot to fuse the kaolin and the silica. And then more recently, there have been people experimenting with solar kilns, but I don't know of anyone that's done more than firing a little pot at a time. So that's not terribly practical, but whoops. But you can, whoops. But solar power can provide electricity that can fire a kiln indirectly. So I'm not going to talk about being sustainable by firing a gas kiln more efficiently, or by having a gas kiln insulated better than another gas kiln, or not reducing as heavily, because 10 years is a short time. So we've got to start transitioning now to no fossil fuel burning. Now, many people say, but what about wood kilns? You know, wood is a renewable source of energy because trees absorb carbon dioxide as they grow wood, and because dead wood will gradually decay and release almost as much carbon dioxide as firing wood. But that's not quite true. It's quite a bit less. And carbon dioxide emissions can be offset, but they can be offset only if replacement wood is grown, and not until that replacement wood has grown. Chris Guston uses an average of 9 cords of wood for each 6 to 7 day firing in his large Onagama kiln in Massachusetts. 1 cord is scrap wood from a cabinet making company, and 8 cords are purchased. He fires 3 times a year. So on the average, he burns 27 cords of wood a year. And in 1 year, 1 acre of New England forest can grow 3/4 of a cord of his 50-50 oak pine mix. So Chris's kiln needs 36 acres of forest solely devoted to supplying him fuel, or solely devoted to sequestering its carbon emissions in order to have a sustainable carbon neutral firing. There are 52 million acres of forest and 34 million people in the New York, New England area. So that's an average of 1.5 acres per person. So wood firers are competing with many other people and wood energy product needs for this precious renewable resource. But our planet needs carbon negative activity in order to keep our atmospheric carbon load below dangerous levels. Using wood as a fuel has the long-range potential of being carbon negative as long as global forest growth exceeds global demand, but currently forests are already hard at work, absorbing 1/3 of the world's carbon dioxide emissions. And there's only half a quart of wood per person globally in the forests that exist at the moment. And wood is needed for building materials, paper, packaging, et cetera, et cetera. So you can't make a good argument for wood firing being okay. As early as 1800 years ago in the Song Dynasty, there was a serious deforestation in China. And 400 years ago in Jingdezhen, the center of porcelain production, fuel had to be gathered from more than 100 miles away and represented 1/3 of the factory's production expense. This is a photograph, and totally polluted the air. This is a photograph from 1920, and now firing with wood in Jingdezhen has been banned, except for in a couple of traditional historic kilns for tourists. And this is, so now they fire with gas, and maybe pretty soon just electric. So how to oh, I was going to get in how to I guess I'm going to talk about here electric. I was going to get a new picture because we're no longer at this studio, but anyway, this is the kiln. My husband's kiln at our home studio uses electricity, and in order for this practice to be green, we pay for 100% green electricity, which is almost 3 cents higher than the basic municipal rate from Eversource at the moment. That's this year's cost. It keeps going up, as you know. By paying this extra, there are many companies that say, oh, buy green energy here, buy green energy there. And I bought green energy from some company called Verde many years ago, which is now being sued for misrepresentation. So if you do get energy credits or renewable energy green, you want to get it locally, and you want to get a class 1 renewable energy credit or renewable source. And in Massachusetts, that electricity is invested in fossil-free wind, water, solar generators within the New England area. So it's helping locally, and it's investing in projects like wind farms that will eventually be able to take over for the 85% gas that's now in the mix of the electricity. It's now generating 85% of the electricity we currently get. So how much does this cost us? So this difference is, if I multiply it by all the kilowatt hours that we spent last year for the house, for the kilns, and for charging 2 electric cars, that additional cost us $300. So, you know, a small percentage of that was for the kilns, the rest is for the home and the cars. But anyway, that's much cheaper. It's a sustainable option that's much cheaper than installing your own wind turbine or solar panels. And how does that relate to? So then I did all these calculations yesterday to see how this might relate to you as a student making ceramics in the kiln at MassArt. just your share of it. We're not worrying about, anyway. So I did all these calculations and I won't. Well, okay, I'll go over it. So this kiln is similar to the 3-ring electrics you have at this school, the bigger ones, at 28 inches deep, 28 inches in diameter. And there is a website I went to that says, you know, normally you might preheat a kiln, drive off the moisture for 7 hours, which for a 15 kilowatt hour kiln, which that is, it's probably using 15% of its power. So it's probably generate using that much kilowatt hours. For the bisque, then the bisque firing is 9 hours, maybe using 50% of the power, using this many kilowatt hours. And then if you fire again, a glaze firing to go in 6, in that same kiln for 10 hours using more power, you could guess that the average kilowatt hours you use to fire that bisque firing and glaze firing together for your work was 182 kilowatt hours. So if we paid with our 24 cents a kilowatt hours, that would cost $43.68 altogether. But since you're firing at MassArt is paying the electrical bill. And if it comes from Eversource, probably only 15% of that bill is renewable energy electricity. The rest is mostly from natural gas. So it's the 85% of the natural gas that's generating the emissions, and it costs it. You need 0.185 kilograms of you produce 0.185 kilograms of carbon dioxide for every kilowatt hour you generate from natural gas. So the bottom line is you would have to pay $2.29 for the carbon emissions from the natural gas powering that electricity per kiln load. So as a student, you could say, okay, I fired a whole kiln load, or over the semester, I must have fired a couple of kiln loads worth, sets of kiln loads, bisque and glaze. So I should buy $5 of carbon credits to offset that. However, but what about the bus you took to school, the food you ate to have enough energy to work in the studio, et cetera, et cetera, et cetera, et cetera. You can go to TerraPass and you can go to individual calculator, and then you can calculate your food and your travel and your home energy and your vehicle and all that, guesstimate how much all that was for a year, and you can buy a carbon offset for the amount of carbon you may have used. And that money will go into generating capacity for more green generation of power.
Nancy, can you just explain a carbon offset a little for people who don't know it?
Yes, so there are a couple. So carbon offsets are offered by many different companies, and some of them. So when you pay a carbon offset, that money could go to a company that is planting a forest, or that money could go to a company that's building a solar energy plant, or that money could go to a company that's building a hydropower dam. So that money is getting invested in something that would offset the carbon that you created. So you are offsetting your, and then there's something called renewable energy credit, which is another way of offsetting whatever energy you use. And the electricity, when I pay for that extra cost of electricity, that goes to renewable energy credits that are invested by the Massachusetts company that manages the offsets for Eversource. I don't know. I can, that's simple. That's a
Yeah,
simple.
no, that's
thing.
good. That helps people understand what they're doing.
Okay. And if you are using that electric kiln and you're going to cone 10, you could really save a lot of energy by going down to cone 6 or going down to 06. Or not firing your clay at all. This is a piece at the Peabody Essex Museum in Salem that came from China centuries ago. And it was never fired. The ceramic head was never fired, the ceramic hands. And this is a piece by Kokoschka at the MFA that was never fired. These are pieces by Roxanne Swensel, unfired Colorado clay mixed with straw. You can see her, see the straw underneath, and it's sort of like a adobe mixture applied to the top. And clay does all sorts of wonderful things and changes when it's a slip and a slurry and drying and cracking. And this is a piece by Patty Rosenblatt where all of this is white slurry slip that's applied to a tar paper. Oh, actually, I think it's just black plastic. I don't think it's tar paper. I think it's just black plastic. And when it dries, it leaves this set of residue of concentric clay rings. And then she photographs them and uses them to make prints. And then this is some wall by Andy Goldsworthy. So there are plenty of options with clay for not firing it. And perhaps with biomimicry, when biomimicry engineering might advance to the point where we can just grow our own pots, the way animals in the ocean grow their own shells. And Marco Polo was so impressed with how similar what porcelain was to the lustrous surface of this cowrie shell that he named it porcellana. And recently, scientists have discovered how to make very strong, lightweight ceramic materials by studying the composition and structure of seashells. Unfortunately, I do not have time to consider the work of the many artists and designers who are addressing issues of sustainability with functional, conceptual, and symbolic work. And to end this talk, I'd just like to share a definition of art that I find very compelling. In the book Homo Aestheticus by Ellen Designac, she describes art making as an essential behavior that evolved to enable cooperating individuals and societies to survive by strengthening the community. So let us imagine how art making might strengthen our evolving community as we develop more sustainable lifestyles and studio practices. And that is the end. So any questions? I don't know if people.
Maybe we can stop the share screen and then.
Yeah.
I'll be able to
Stop,
see the
square,
chat.
escape. Yes, oh, I stop, you are sharing, stop share.
I
Okay,
know there were a few questions in the chat also, but also please, anybody, you're welcome to interrupt. I'm going to kind of go back. I saw one. Oops, now I lost the chat. Oh, no, I didn't. I am looking for Olivia Curtis. Can you, you had a question you wrote in there. Can you share that with Nancy?
Sure. I just wanted to ask about kind of offset companies and if they're regulated, if there's, if there's any research showing like, oh, if you donate to this company, they're actually going to do what they say they're doing, or is there any like, we see greenwashing all across the board now.
right.
Yeah.
Let's see, I'm gonna go to full screen. I, when I was wondering what company to use, I went online, and did some searches to see which companies were valued, had been vetted, by other companies. There's a Massachusetts resource, green energy resource. I don't know, committee, group, organization, whatever. That might be a good place to start especially for if you want to invest in local infrastructure. And if there's a copy of this slide, if we go back to that slide where I talked about the cost of green energy, it's the information and the exact title of this organization is there. Or I can look, but yeah, there's so much, it's such a critical need now. There are a lot of evaluations online that you can find of these about the companies.
Does anybody else have any other questions for Nancy? This has been very informative, and I know it's just sort of the tip of the iceberg of what can be done.
Should we look at, are there chat questions we should look at?
I'm trying to, because Esvades, you come over here.
Let's see.
Oh, wait, now it pops up. We're just having trouble getting the chat to come up, and that's why.
I can see it. Let's see.
Okay, if you can see it, yeah.
Oh, carbon offset biomimicry. Read, someone's, Ben, read Janine Benyu's book. Thank you. Okay.
Yes, on the podcast On Being, Krista Tippett's podcast has been on the air for decades. This last weekend, she spoke with Janine Benyus for an hour, and it was so enlightening. Ford Motor Company, among other companies, are after her just to have her help them because they're running out of resources. And they recognize that the only way to do this is be working as naturally as possible. And she had so much to talk about in terms of how we can reduce our carbon, footprint.
Oh, great. Thank you, Ben. I'm going to go read it right now.
Anybody have questions?
Actually, but I want to be able to show. Okay, got it. Oh, Golden Paint sells that that Yin Min blue already. Oh, that's interesting.
I also had added into the chat that Yi Design and Carolyn Chang, when Nancy was giving a reference to who's doing, that's on an industrial scale in China, as far as recreating products that can be used as building materials, but they're also separating all those and grinding down porcelain. So they're actually recreating color. So they have blue and they have reds, because they're doing such on a mass scale. But on an individual scale, Deb Schwarzkopf out at Rat City Studios in Seattle has been creating these paver bricks, by literally, it is something that, yes, you can take it, you can take pieces you don't want, your wasters, to a construction company because it's considered clean fill. But if you also break them down, and there are what are called hammer mills, break this stuff down and actually add it into pieces. But she's also doing, Deb is doing a lot of just taking all the sink glop and putting that over into bricks. She's mixing it in with waste clay, and then, you know, just keeping things out of landfills. That's the most important
Yeah.
thing. I know
Yeah,
that
it's a
also
big commitment to
Yeah.
do that. Yeah, it's great.
the studio, the EKVWC, you know, Sunday morning out in Amsterdam is actually working on a way to grow their own plastic so that they won't have any plastic in the studio.
Oh.
And they're looking at even the idea of, and we do a lot of recycled plastic here, but they're really trying to limit the amount of plastic that's actually in the studios.
Great. Right, I forgot about all that plastic.
You know, in Cincinnati and in Sika, aside from some remarkable emerging artists and opening and closing ceremony talks, among other things, we went to see Lisa Orr's rocket kiln being fired out at Queen City Studios. Using scrap, in her case, they were using scrap drawers from cabinets. And I'm talking only maybe like 1 or 2 drawers to fire a kiln the size of, you mentioned before, that your husband fires.
Right,
2 rings put up on top of simple brick splits and a little bit minimal cable. She fired that kiln from a cold 40 degrees outside. It was cold and wet.
right.
Over 1800 degrees in an hour and 15 minutes. Her pieces were in there. So she was quite secure with how well they were going to fire. And now
Right.
they moved from Texas, from Austin, up to Northborough, living in Massachusetts now. That is how she's firing all her work.
Really?
There's almost no, there was zero smoke, zero evidence of any reduction. It was about the cleanest thing I've ever seen.
Wow, that's amazing.
Amazing, yeah.
Okay.
And some people have been introduced to rocket kilns here because it's part of Objects That Change Lives course, but we're using those as a cooking utensil, and they really are traditionally used around the world to stop deforestation, where cooking is the main reason we're deforesting.
Huh.
Yeah, thank you for bringing up the issue of wood kilns. It doesn't get discussed very often in public. It's a sensitive issue. We're stepping on people's artistic toes, but it has to be discussed. I mean, that's a lot of wood.
Yes.
So, many forests.
Margie just put up in the chat here, yes, out here on the second floor of the North Building is from Objects That Change Lives. They are showing the water filters. Jody Burr is running that class this semester. It is, that course has been moved now permanently to a fall only class. So it is on the schedule right now. If anyone's interested in this, that you could, you know, putting in a plug for it, it is available for you to take that course in the fall. And it covers all kinds of things related to sustainability in many ways. When we did the talk, we did a sustainable futures talk that I had at the NCECA this time, and Julia Galloway was on the panel with me, and I will get, of course, this is of more interest to those of you in the ceramics community, but I'll get a list of the artists who are really have totally changed their practices. And in the clay world, a lot of that is thinking about how do you buy your materials locally? And they're very concerned about shipping and what can happen with just stop shipping things, or how to remove bubble wrap from our system. And I'm on the Green Task Force for NCECA, and if those students who were there with me saw a machine, it's a cardboard shredder machine that actually is replacing. So there's all kinds of ways. But Julia presented a number of artists who are also not just changing like how they're doing things, but also bringing awareness with what they're doing. And I'm not going to remember the name, but I will get the list of the slides. But artists who are really kind of putting You know, the one artist who was very concerned about the amount of plastic in the ocean. And so all the imagery on the work that's being created is kind of like a little bit of a reminder of what's going on, so that people think about it in their own, like when they make a decision about that piece of plastic that's out there and what to do about it. The third young woman who was with me on that panel, and some of the students saw this, was Nicole Ham. She's working out in Montana and very concerned about mining issues. And in all of our materials, wherever they're coming from, and as Nancy, as you said, technology is really gobbling up probably much more of these materials than what an artist is, but it still doesn't mean we can't do our part. A cell phone, everybody's got a cell phone in their pocket. It's got the equivalent of 2 to 4 pennies worth of the material that was created for cobalt. There's a terrifying book that's out right now. It's called Cobalt Red, and really scary with just kind of, and color of it is not red, it's the bloody issues of it. You know, a laptop has something like a pound's worth of cobalt in it. A full scale, you know, a larger electric battery goes up to like 4 pounds. So it's crazy what we're up against. They just are opening up a new cobalt mine out in Idaho because the United States wants to be more in control of their minerals and how they mine things. So our mining laws are pretty, you know, that's why there's this battle over going into indigenous lands to mine things. But what Nicole's issue was that a lot of the materials are then sent to Norway, or as Nancy, as you said, Iceland, where they do have hydro processing. So everything is shipped. Anything that we're getting locally, if you're getting cobalt, it might have been mined. Look at where your materials have been mined. Where were they processed? Where were they refined? Refining is huge, the amount of shipping that's going on, and then till it finally, so she was tracking and found like her little pound of clay had already traveled like 10,000 miles before it ever got to her. And what can you do to get things more local? So
is that talk recorded and accessible, Jana? Your presentation at NCECA?
They did not record that one, I don't think, but we're gonna put all the materials that we have up on the Green Task Force. If you go to NCECA and Green Task Force, all of our resources are there. So the three of us, we haven't been back long enough here to get it together, but we're going to sort of recreate a digital version, you know, a version that can be shared with a lot of information that's there.
Great. Okay.
Anyhow, I want to take in any other questions here too. Anybody, guys, you want to know anything else? Well, we got Nancy, the expert. I think this has been amazing, Nancy. You've touched a lot on what people need to think about. So
yeah, I forgot about the time on that cell phone, maybe worse than that firing.
Yes. Yes.
And slightly off subject, Nancy, if people have not been experienced your work very much, they should definitely do some research, because those pieces, all your pieces for many years, but the ones I've been seeing down in the sculpture gallery, oh, those aluminum pieces are stunning. And I appreciate your taking responsibility for knowing exactly what you're doing and how it affects.
Not exactly, but trying.
But you had a new public art piece that just opened here in Boston, right?
At the Green Lines, the extended Green Line station in Medford at Tufts. Yeah.
Okay.
Glass. It was sort of ceramic related because it ended up being glass.
Yeah.
Fired glass. There's a company about an hour west of here, and the whole factory is just all these tables with little roller wheels on them, and these huge panes of glass go motoring around, and then they print on the glass with you know, ceramic materials, and that's fused in some kiln. And
I can't wait.
All right. Well, if we have no more questions, I know some people are getting ready to run out the door. You guys are good here in the room. So
Okay, thank you all.
thank you, Nancy. I'll be in touch.
Okay,
Okay.
great.
All right. Thank you. Bye.
Bye.